All right, so this is the follow-up video with Mr. Tran's method for partitioning a line without a graph. But here we have the graph, right? So let's take a look at this. This was from the old video. Just to recap, you had here point A, which is at -5, 4, and point B, which was at 10, -6, right? So it's all the way down here. And then what did they want? They wanted a ratio of 1 to 4, right? Split up, okay? And so we can do this without the graph, right? And how is that possible? By actually just looking at the coordinates. But first, before we do that, we make a look at the ratios first. If they're requesting something to be in a 1 to 4 ratio, 1 piece plus 4 pieces gives us a grand total of 5 pieces, right? You can scale up this ratio by multiplying it by 2. So 1/4 times 2 is 2 over 8. 1/4 times 3 is 3 over 12. And then 2 over 8 gives me a grand total of 15 pieces. 3 plus 12 gives me a grand total of 15 pieces. Okay, with that said, how can I use what I know to actually to get the answer without actually constructing a graph? It's very easy. Here, point A, -5, 4, right? And we're going to put point B on the bottom, which is going to be 10, -6, right? And so the same two questions that you always want to ask yourself, it's always around the same thing, right? But this is literally a giant thing where you ask yourself, okay, how do you get from -5 to 10? Well, we had to add 15. That means there's going to be 15 spaces. If there are 15 spaces, that means the ratio is going to be from 3 to 12. Now, I don't know where yet, so what I'm going to do is I'm going to look at my lowest number, which is 3. And so that means that I'm going to be counting by 3. I'm going to be adding 3 until I get up to 10, right? So let's take a look at this. -5 plus 3 is -2, plus 3 again is +1, plus 3 again is +4, plus 3 again is +7, plus 3 again gets me to 10. Okay. So now I know there's 1, 2, 3, 4, 5, 6 possible coordinates. I need to do this side. How do I go from 4 to -6? I gotta subtract 10. Okay, if I have 10, that means I'm going to be partitioning up this entire line into pieces of 2, right? So now I'm going to be subtracting 2 all the way until I get to -6. So 4 minus 2 is 2, 2 minus 2 is 0, 0 minus 2 is -2, minus 2 again is -4, minus 2 again is -6. So here we go. Now we have literally all 6 points, right? 1, 2, 3, 4, 5, 6. And all 6 points here is reflected on this graph here, okay? So now the question becomes, it's like, what point do you want to, what is the correct valid point that's going to make it a 1 to 4 ratio from A, right? And so the correct point has to be, right? I'm going to just give this coordinates. The correct point has to be this one. Why? Why that one in particular? Well, because there's a space between -5 and 4, right? This is like a space right there. And then the rest of the space, I'm just going to highlight in green maybe, right? So there's a space between here, there's a space between there, space between there, and a space between there. And if you take a look at this, what's the ratio of the orange spaces to the green spaces? Well, it's going to be 1 to 4. And then you could see on this graph, and maybe I should have color-coded it, but here, this is the first point right there, right? That's 1. And then how many green spaces are there going to be? 1, 2, 3, 4. There we go. This is clearly in a ratio of 1 to 4.